Now we have studied about half-wave rectifier. In half-wave rectifier, efficiency is very less and quality of DC is poor. So we can get better quality DC by using full-wave rectifier. Now full-wave rectifier circuit diagram is like this. In full-wave rectifier, again this transformer is used. This transformer converts given AC into required AC. But in this case, simple transformer is used, therefore cost of the circuit is less. Now in this case, center tap transformer is used. Instead of one diode, two diodes are used. Then this is load resistance and output is taken across load resistance. Now construction of the circuit is like this. This is input AC which is to be rectified. It is connected to primary windings of the transformer. Secondary windings are connected to anodes of diode D1 and D2. These are anodes of diode D1 and D2. Then cathode of D1 and D2 connected together. This common cathode K is connected to center tap through load resistance and output is taken across load resistance. This is construction of the circuit. Now in this half-wave rectifier, working of the circuit is such that now during positive half cycle, when S1 is at positive potential, S2 is at negative potential. So S1 is at positive potential, therefore this diode D1 conducts. And this diode is in forward bias because positive is connected to anode and this negative is connected to anode. Therefore this diode is in reverse bias and this diode is in forward bias. In forward bias diode conducts. Therefore current flows from S1 to D1 to common cathode K. Now this diode is in reverse bias. There are two paths for current flow. But this is reverse bias, so its resistance is infinity. So current cannot flow through this path. So current flows from A through load resistance B to center tap to S1. So this is path of the circuit during positive half cycle. Means when S1 is at positive half cycle, diode D1 conducts and D2 remains off. And current flows from S1 to D1 to K to A through RL to B to center tap to S1. This C means center tap. Now if we consider waveform, now this is input AC and this is output voltage. Now when diode D1 conducts, we get output voltage D1. For positive half cycle, diode D1 conducts, due to diode D1 we get output. During next half cycle, when S1 is at negative potential and S2 is at positive potential, now this negative is given to anode of diode D1. So this diode is in reverse bias. Now positive is given to this anode. Now diode D2 is in forward bias. So current flows from S2 to D2 to common cathode K. Again, there are two paths for current, but diode D1 is in reverse bias. Its resistance is infinity, so current cannot flow through this path. Current flows from A through RL to center tap to S2. Means during negative half cycle, diode D2 conducts and we get output. Again, positive half cycle comes here. Again, diode D1 conducts and we get output due to diode D1. During next half cycle, diode D2 conducts and we get output. Again, diode D1 conducts and we get output. In this way, full wave is converted into DC. So it is known as full wave rectifier. When diode D1 conducts or D2 conducts, current flows from A to B. Current is unidirectional. When diode D1 conducts or diode D2 conducts, current flows in one direction only. So this is known as rectifier. Means output is DC. But this is not pure DC. But quality of DC is better than half-wave rectifier. In this case, ripple factor. In this case, ripple factor is 1.21. In this case, 0.48. Ripple factor. Then, output frequency is equal to 2 times input frequency. For example, in this time interval, one cycle of input is completed. In half time, one cycle of output is completed. Means when one cycle of input is completed, 2 cycles of outputs are completed. Means frequency becomes 2 times input frequency. Then efficiency is twice, so 81.2%. Then output voltage is equal to 2 times Vp upon pi. Then output current is equal to 2 times Ip upon pi. These are the parameters of the full wave rectifier. If we compare this and this circuit contains simple transformer. This contains center tap transformer. So cost of center tap transformer is more compared to simple transformer. In this case, single diode is used. Now in this case, one more point is peak inverse voltage. In this case, peak inverse voltage is the maximum reverse voltage for which diode withstand without damaging. That voltage is Vp. Means if reverse voltage Vp is applied, then also diode should withstand. It should not get damaged. Now in this case, that peak inverse voltage is 2 times Vp. Means for this voltage, diode should remain off. It should not get damaged in reverse bias. So cost of these two diodes is more because its peak inverse voltage is more. So question will be like this. If input frequency is 50 Hz, in this case, half-wave rectifier, what is the output frequency of ripple? Input is 50, output is also 50. Now in this case, if input frequency is 50 Hz, what is the output frequency? It will be 100 Hz, 2 times. Ripple frequency becomes 2 times. What is efficiency of that circuit? Efficiency is 40.6. In this case, efficiency is more because positive, negative half, both half cycle will get output 2 times. Output voltage is more, output current is more, so higher level output is